Hello and welcome to Forrester High School Maths Department's National 5 Math Support Materials. My name is Mr. McDonald and I'll be talking you through your subject today. Today our learning intentions are to understand the basics of trigonometry and to be able to find missing sides of a right angle triangle using sine, cos and tan. Now none of those words will mean anything to you yet, but we'll explain what those mean during the lesson. Our success criteria are that I can use my knowledge of trigonometry to find missing sides and angles of triangles. Today we're just going to focus on the side lengths of right angle triangles, and then in the next lesson we'll look at angles of right angle triangles. So first of all, to fill you in on the word trigonometry. Trigonometry comes from two different Latin words. The first one is trigon, which means three-sided shape, and the second one is metron, which means measurement. So if you put those two words together, trigon and metron, you get trigonometry, and that means the measurement of three-sided shapes, or the measurement of triangles. Okay, so we've already done a bit of trigonometry with our work on Pythagoras theory so far, because that is part of measuring three-sided shapes as well. But in a more general sense, this is the first part of trigonometry that we're going to look at. The first thing we need to know is how to talk about side lengths. So we know already from Pythagoras theory that the opposite side of a right angle is called the hypotenuse. However, what we don't know yet is that if we're given another angle in this triangle, then the two legs of the triangle, the shorter sides, have names as well. The one that's opposite the given angle is called the opposite side. It's not a very original name. And the one that's adjacent to or next to the given angle is called the adjacent side. Again, not a particularly inventive name, but it helps us remember exactly why they're called that as well. Make sure you take a note of this in your jotter, and then we'll move on to the next part. Pause the video here to take your note, and when you're ready, you can move on to the next section. Okay, so as well as the right angle triangle having three different side lengths with different names, the trigonometric ratios can be found by using those side lengths in certain ways. Ratios are just, remember, one thing divided by another in equal proportions. So sine x is equal to the opposite side length divided by the hypotenuse side length. Cos x is the adjacent side length divided by the hypotenuse side length. And tan x is the opposite side length divided by the adjacent side length. The way I like to remember that is with the mnemonic SOHCAHTOA. It's written down beside here. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. SOHCAHTOA. There's lots of different ways to remember SOHCAHTOA. Either you can just memorize it because it is a strange sounding word. You can create a mnemonic, so something like some old horse caught another horse taking oats away, or some old Harry caught an aging Hagrid taking on Azkaban, or the one my teenager pupils tend to like the most is some old hippie caught another hippie tripping on acid. I don't know what hippies are doing in the chemistry classroom, but that is the one that seems to stick in people's memory the most. Again, make sure this is copied into your notes. Pause the video here and then move on when you've taken your note and you're ready to start on the next part of this video. Okay, so here's a practical example of what all that information actually means. All right, so here we have a given angle in a right angled triangle. So our given angle is 45 degrees, and we know it's a right angled triangle because of this right angled triangle side here. The first thing we have to do is figure out what side lengths we have got and what side lengths are completely blank. Okay, so in this triangle, I've got the side that's opposite the right angle, that's the hypotenuse. And I do have information about the opposite side as well as it's just x. It is still information, whereas the side for adjacent is completely blank. So we're not going to be using that in our calculation here. Okay, so because we've got the opposite and the hypotenuse, if we write out our SOHCAHTOA, SOHCAHTOA, you can note that we've got the opposite and the hypotenuse side. That is the two sides that match with sine. So we can start our trigonometry question with sine x, because we've just decided those are the two sides that we need for sine x, is equal to opposite over hypotenuse. Then what we can do is we can put in the information that we know. So instead of saying sine x, we can say sine 45 is equal to the opposite side, which is x, divided by the hypotenuse side, which in this case is 30 centimeters. I don't need to put the centimeters in, I'm just going to use the number 30. To finish off this example and find an answer for whatever my missing side length is, x, I am going to multiply both sides of this equation by 30. And what that does is it removes the denominator from this fraction and multiplies the left-hand side of this equation by 30 instead. So we'll finish off with 30 sine 45 is equal to x. Then if you put 30 sine 45 into your scientific calculator, you get that x is equal to 21.21 centimeters to 2 decimal places. If you're having trouble getting that on your scientific calculator, it might be that you have to put in between the 30 and the sine 45 a little multiply sign. So you might have to write down 30 times sine 45 is equal to x. If you're using a phone calculator, you might find even more difficulty with this. You might have to put the 45 in first, then press the sine button, and then multiply it by 30. Phone calculators are a little bit backwards, and that's why we always recommend that you get a scientific calculator for doing National 5 Maths. Okay, what I'd like you to do now is I would like you to do the first activity that I'm leaving on your teams. Now what that is it's not calculating missing side lengths with trigonometry. All you're doing is you're deciding, am I using sine x, tan x, or cos x? And to do that, you have to use SOHCAHTOA. So make sure you've got that a note down in your jotter already. And if you've not, make sure you get a note of SOHCAHTOA so you can decide which of these three trig ratios that you have to use for activity 1. Pause the video here, complete activity 1, and then come back to me for a little bit more instruction. Okay, so now you should have completed activity 1. Let's just recap on those skills that we should have from that activity. So you should be able to identify which sides in a right angled triangle you have. So in the case of this pink triangle here, we've got the opposite side and the adjacent side. In the orange triangle, we have got the opposite side and the hypotenuse. And on this triangle down the bottom here, we have got the adjacent side and the hypotenuse. From there, what we should be able to do is decide on which trig function is going to help us to solve this question. So if you've got the opposite and the adjacent, as part of SOHCAHTOA, the TOA part of SOHCAHTOA is the one that matches the opposite and the adjacent. So we should be using tan x equals opposite over adjacent for this one. For the orange one, we've got the O and the H. That goes with SOH from SOHCAHTOA. So we should be using sin x equals over h for this example. And for the last example, we've got A and H, so that's K in SOHCAHTOA, and we'll be using cos x equals A over h. All right, I flew through that quite quickly, but hopefully after you've tried a good few examples, you'll be as quick as I am at identifying the sides that we have, and also then linking that to a trig function as well. Okay, so moving on. This is how we completed our trig function before. I'm going to do a few more examples of this with you, and then I'm going to get you to do a few for yourself. Okay, so starting off, once again, I'm going to write down SOHCAHTOA. So we've got all three possibilities for our trig question down. So it's either sine is opposite over hypotenuse, cos is adjacent over hypotenuse, or tan is opposite over adjacent. We're then going to identify our side lengths. So we've got the opposite side here, and we've got the one right next to our 35 degrees as well. That's the adjacent side. Our right angle, which is here, and our hypotenuse, which is across, is completely blank. So we're not going to be using that. So with our opposite and adjacent side, that set of side lengths on a right angle triangle matches with the TOA part of SOHCAHTOA. That means we're using the trig function tan x is equal to opposite over adjacent. Substituting in the information that we know from our diagram, we don't have tan x anymore because we know what that angle is. We know it's tan 35. That's equal to our opposite side, which is our missing length. That's our x variable. And our adjacent, which is 2 centimeters in this case. To sort out this equation, I need to multiply both sides of my equation by 2. That helps me get rid of the fraction on the right-hand side and just gives me 2 lots of whatever is on the left-hand side of the equation. So I've got 2 lots of tan 35, which is just a number. Is equal to x. Put that into your scientific calculator and you get the answer that x is equal to 1.4 centimeters. Okay, that's how it's done. The steps are, first of all, figure out what your trig function is. What function? Oops. Okay, I'm going to put f with a wee n at the top as a shorthand for function. What function are we using? Then substitute in your values. What information do we have from the diagram that we can put into our equation? Third step, rearrange your equation so that x is the subject. And then finally, by getting your answer, you've completed this question. So I'll just put calculate because you have to use a calculator. It is definitely worth having, if you don't have already, at least one example of this fully worked in your jotter. So if you don't have it, copy it into your jotter now. If you do have it, just wait one moment and I'll move on to the next example. Pause the video here so that you can get that written down into your notes jotter, or just wait a second until I move on. Okay, final example. This is the last one that we're going to do, and then I'm going to unleash you on a few of your own. SOHCAHTOA, get into the habit of writing that down at the start, even if it is a little bit redundant once you've done this a few times. Identify the side lengths that you have. So we have the hypotenuse here because that's the one that's opposite the right angle. We have got the adjacent here because that's the one that's next to the given angle. I've mixed it up a little bit by putting the given angle at the top of this triangle, which doesn't change a huge amount, but it does change which sides are your adjacent and your opposite. And then my opposite side is the one that's opposite the 30 degrees, and we're not going to be using that in our calculation. So the triple that our A and H belong in is the cos triple, K. And we're going to say that cos x is equal to A over H. The letter that goes on the top of your fraction is the first one that appears in SOHCAHTOA, and the letter that goes on the bottom of your fraction is the second one that appears in SOHCAHTOA after your trig function letter. So because A comes before H, A goes on the top of the fraction, H goes on the bottom of the fraction. Step 2, substitute in what you know. So cos x changes to cos 30. The adjacent side changes to our x, our unknown value, our variable, and the h changes to 23 centimeters, the length of our hypotenuse. Same as before, we're going to multiply both sides by the number on the bottom of our fraction, the denominator, to get rid of it, and we'll just get 23 times whatever is on the left-hand side of our equation instead. So 23 cos 30s. Remember, cos 30 can just be thought of as a number, so we're multiplying that number by 23 to get what x is. Put that in your calculator, and x is equal to 19.92 centimeters. One small thing, if you're not managing to get these numbers from your calculator, it might be that you have got your calculator on the wrong angle function. So there are 3 letters that you could see appearing at the top of your calculator: D for degrees, R for radians, and G for gradient. You want your calculator to be on the setting that displays a D at the top of it for degrees. That's because we're working with angles that are in degrees in our trig functions. So if you don't see a D at the top of your calculator and you're getting the wrong answers, then try and find a button on your calculator that says mode or setup, and try and click your letter to D at the top. If you can't do that, then perhaps the teacher that's covering for you can help you out as well. Okay, so your next challenge is to look at these 3 triangles, decide on which trig functions you're going to use, and then find the lengths of A, B, and D in these triangles. Once you've done that, I'll put the answers on the next slide that I'm using. So pause the video here if you don't want to see the answers, and I'll show you fully completed solutions in just a moment. Okay, so here are our solutions. For the first one, A is equal to 6.88 centimeters. I've made a small change to the third line of working there, where I keep the A on the left-hand side as the subject instead of the right-hand side. It doesn't matter. Also, if you use the letter X to denote your missing side instead of A, that's totally fine. Don't worry about that. In the second one, you should have 12.86 centimeters for B, or your X value for the second one. And for the third one, for D is 6.45 centimeters. All three of these triangles use sine X. I wanted to make sure that you had that down and that you could spot that it was sine X in each different case. If you didn't, then you need to go back and look at how SOHCAHTOA works and maybe look at how you identified triangles in that first exercise. Okay, moving on to exercise 2. What I'd like you to do is attempt question 1, which is this time a mix of different trig functions. So it's not going to be sine every time. You're going to have to figure out whether it is sine, which is the opposite in hypotenuse that you have, whether it's cos, which is the adjacent in the hypotenuse you have, or whether it's tan, which is the opposite in the adjacent that you have. Okay, do question 1 and question 1 only. Don't move on to question 2 because that throws in an extra different level of difficulty there. Once you've completed question 1, come back to this screen and then I'll give you a little bit more instruction. Okay, you're almost there. We're going to do one more type of example and then I'll let you finish off that activity that you just started. Okay, so this type of example comes with if you are missing value, if the x that you were looking for happens to be on the bottom of the fraction instead of the top of the fraction of your trig ratio. Okay, so doing all the same steps as before, writing out SOHCAHTOA, identifying which side lengths that you have as well. I'm just glancing over here. I can see that we've got the hypotenuse, which is our x value, and we've got the opposite, which is our numbered value there across from the angle that we've been given. So we're going to be using the opposite in hypotenuse. We're going to be using sine. So sine x equals O over h, opposite over hypotenuse. Sine 64 is what we'll get when we substitute in our values. And that's going to be equal to the opposite side, which is 10, divided by the hypotenuse side, which is x. That doesn't help us wonderfully. Doing the same thing as we always do. We're going to multiply by x on both sides. So I shouldn't be writing x as a curly x. We're going to times by x and times by x. One's a straight multiply sign, one is a curly x. And then we're going to get x times by sine 64 equals 10. Now remember in the previous examples when I was saying things like sine 64, cos 21, tan 150, they're all just numbers. Okay, so to finish this off, what we're going to do to get x on its own, we're going to divide by sine 64. That way, x will be on its own as the subject of the equation, and we'll be left with our answer that we have to type into our calculator to get a real value for. Okay, so x is equal to 10 divided by sine 64. An extra line of work in there, and then putting that into your calculator. Remember, the fraction line just means divide. You should get an answer of 11.13 centimeters. That's how you complete a question where x, our variable, is on the bottom of the fraction instead of the top of the fraction, which is what you've been dealing with so far. There's an extra step of arranging that equation so that x is the subject. All right, we'll do one more example of that, which you can copy down in your notes jotter, and then we will go back to that activity that we'd just done. So once again, SOHCAHTOA, those are our three different trig functions: sine, cos, tan, SOHCAHTOA, some old hippie caught another hippie tripping on acid, clumsy hippie. Okay, right, our identified angle, 27 degrees, is at the top of our triangle here, so that makes our 10 centimeters our opposite side, and our adjacent side equal to x. If we've got the opposite and the adjacent, we are using tan as a trig function. So I'm going to start my working with tan x equals opposite over adjacent. Filling in the information we know, tan 27 as our angle is equal to our opposite, which is 10, divided by our adjacent, which is x. We can multiply both sides by x times straight curly x times sine straight x is curly. Can multiply by x on both sides and we get x tan 27 is equal to 10. And again, we're going to divide by tan 27. On both sides of this equation. And that will get us, sorry, that says tan 27. That will get us x on its own as the subject of the equation. So to finish this off, x is equal to 10 divided by tan 27. And so x is equal to 19.63 centimeters. Okay, that one is worth getting down in your jotter if you haven't already copied one of these down as a note. Then what I'd like you to do after that is I would like you to go on and do questions 2 and 3 of your activity in teams. Activity number 2, questions 2 and 3. One small thing to note before I go is that although this looks complicated, one small thing that you can do to speed this up for yourself, and it is a bit of a cheat, but it works out every time, is you can swap the x and the trig function in your equation. If you notice that sine 64 is equal to 10 divided by x, and later on it says that x is equal to 10 divided by sine 64. If you swap the x in the sine 64's position, you can miss out that line of working that is in between. Again, it happens the same way here. If I swap that x in the tan 27 around in my equation, I immediately get this situation here. Okay, so that might speed you up a little bit with questions 2 and 3. Complete questions 2 and 3 now, and I will see you again tomorrow, or sorry, on Wednesday, for another lesson.